Okay, so I'm back. The rain is over. So, okay. Okay, now let's go to the non-experiments. Okay, so as I've said earlier, not all of our studies in biopsychology can be done in experimental designs. So there are certain ways to study the functions of the brain, the different structures or parts, and interventions in other ways. So we have non-experiments. So we have quasi-experimental studies. So we have here studies of groups of subjects exposed to conditions in the real world. Then not real experiments, as potential confounded variables have not been controlled. Okay, so an example for this are smoking studies. Of course, we won't let healthy, non-smoking people smoke just to know what part of the brains or what part of the brain is affected, or whatever cognitive performance are affected due to this habit. So we just use people who are already smoking and look at them, for example, in the MRI, let them do some tests, etc., etc. Of course, we also have case studies, so it focuses on single cases or subjects, single subject or single case. So one example is Phineas Gage, which I will be telling you in depth later. It gives us a more in-depth and more focused view or approach to this certain phenomena, and it's a good source of testable hypothesis. However, the main disadvantage of this is the degree in which we can generalize it to the whole population, because it's just an isolated case, for example. So here is the case of Phineas Gage. Okay. So he had this railroad accident in the middle 1980s. So sa Phineas, no? And as he was preparing to blow up some rock, a spark set off his gunpowder and blew an iron tamping rod through his head, entering below his left eye and exiting through the top of his skull. So as you can see on that illustration there. So miraculously, Gage survived the accident, but he was not the same man as he was before. Before, he was responsible, friendly, and polite. After the accident, he had difficulty holding a job and was profane and irritable. His memory and reason were intact, but his personality was greatly changed for worse. So the major part of his brain that was affected was the dorsolateral prefrontal cortex, in which people who has damage in this part of the brain experience apathy, personality change, and the lack of ability to plan. When we say apathy, there is no care, okay? They also have challenges in emotion regulation and also in impulsivity, so there are emotional disturbances. So with this case study, we were able to relate this to other mental disorders, such as some mental disorders that are showing the same symptoms. So we have here schizophrenia, in which people have lower than normal activity in their frontal lobe. And we also have the attention deficit or hyperactivity disorder, or ADHD, in which impulsive impulsivity and short attention spans are observed. They also have this underactivity in the frontal lobes. And lastly, the extreme antisocial disorder or behavior, in which um, serial murderers also manifest this, and they frequently show a damage to their orbitofrontal cortex. So with this, no, we were able to derive certain conclusions based on that one single case study. All right. So that's one example. So we cannot do that in experiments alone. Now, in the case of pure and applied research, we know that, as I have said earlier, pure research or basic research is conducted for the purpose of acquiring knowledge itself. And we also have applied research that is intended to bring about some direct benefit to humankind. So, many scientists believe that pure research will ultimately prove to be more practical benefit than applied research. However, pure research is more vulnerable to political regulation because politicians, of course, and voting public have difficulty in understanding why research of no immediate practical benefit should be supported. Just like in many other researches, such as looking into the electrochemical signals in squids, diba? So not all people will be able to get relevance from it. But now that we know about it, it became a Nobel Prize research, or discovery. It has an award, and it has been part of different books. That indeed, electrochemical signals are what makes up our brains, or what helps in brain function, no? But if we will look at that in applied research, they will ask for grants. That's always the question there. How will this be helpful to the populace, to policy making? All right. So if you will have your papers to be submitted in grants, for example, in the USD, in CHED, that's always the question. It should be part of the significance of the study. Okay. However, many research projects have elements of both. So it's not either or. It's not, is it pure or is it applied? But usually it's a combination of both. Now we go to the different divisions of biopsychology. So we're done with explaining what biopsychology is all about, what are the different related disciplines in neuroscience, and also what research is. How do we use research in biopsychology? Now we look into the different divisions of biopsychology. Each of the divisions have different approaches, but they overlap. Okay. So we have there physiological psychology, neuropsychology, psychopharmacology, cognitive neuroscience, psychophysiology, comparative psychology. Alright, so physiological psychology is the division that studies the neural mechanisms of the behavior. It uses direct manipulation of brain in controlled experiments. So here there's really the direct manipulation. That's the keyword, okay? like surgical and electrical methods of brain manipulation. It studies usually laboratory animals, and it's really have an inclination for pure research. Psychopharmacology, on the other hand, is similar to physiological psychology. It focuses on manipulation of neural activity and behavior of drugs. So if before, it's more of direct manipulation directly on the animals, on the workings of the brain through surgery and electrical manipulation. Here, it's more on neural activity. Substantial portion of the research is more on the applied. Neuropsychology, on the other hand, is the psychological effects of brain damage in human patients. It cannot be studied in humans by experimentation, and it focuses on case studies and quasi-experimental studies. So, yeah. So just like in the smoking studies, we can look on the psychological effects of certain brain damage that it may have had an effect, or in alcoholism, for example. It's focused on cerebral cortex, and usually it's more on damages caused by accidents or surgeries, and it has more applied on biopsychological subdisciplines. Psychophysiology, on the other hand, has a relationship between physiological activity and psychological processes in human subjects. So in this part naman, we use non-invasive procedures. Okay, so here the EEG, or the electroencephalogram, measures of the eye. Okay, so other common psychophysiological measures are muscle tension, eye movement, several indicators of autonomic nervous system activity, just like heart rate, blood pressure, pupil dilation, and electrical conductance of the skin. Most of the psychophysiological research focuses on understanding physiology of psychological processes, such as attention, emotion, and information processing. And there has also been a number of interesting clinical applications of the psychophysiological method. So in the example, in the illustration here, we have psychophysiological experiments have been conducted with people of schizophrenia, that they have a difficulty on smoothly tracking a moving object such as a pendulum. Alright, so in normal, on the C, in the normal subject, normal control, it's very smooth, it's just okay. However, on different schizophrenic subjects in the S1, S2, and S3, they have this difficulty. Alright, and that is why if you will look into, if you already have had your abnormal psychology, in schizophrenia, we have there one symptom that we focus on, which is hallucination. So with that, with the difficulty that they have in focusing on the pendulum, in the focusing their sight on it, it gives us an idea that there is really a distortion, on their view of reality, and it has a certain, we can say that to a certain extent, it has a relation on their brain activity. And we use there the EEG, Next is the cognitive neuroscience. It's the newest division of biopsychology, and it focuses on neural basis of cognition. When we say cognition, it's a term that is referred to higher intellectual processes such as thought, memory, attention, and complex perceptual processes. Often, it employs human subjects, and the key method for this is the fMRI, or the functional brain imaging techniques, such as that, or the MRI. Cognitive neuroscience involves collaborations between researchers with different backgrounds. So, just like in biopsychology, cognitive psychology, computer science as well. Lastly, we have there comparative psychology. It deals with the biology of behavior, and it compares different species to understand evolution, genetics, and adaptiveness of behavior. It uses laboratory or ethological research. When we say ethological research, it's the study of animal behavior on its natural environment, such as yung example, if you're familiar with the imprinting phenomenon by Conrad Lawrence. So it happened when the ducks, the newly hatched ducks, have this view that their parent is Conrad Lawrence. So that's why they followed him everywhere. So that's what we call imprinting. Alright? And the areas of research that often employs comparative analysis are evolutionary psychology. So it's understanding the behavior through its evolutionary origins. And behavioral genetics, it's on the understanding of genetic influences on behavior. Alright, so I hope that you will be able to imprint. Imprint talaga. I hope that you will be able to crystallize the information, and to delineate, compare, and contrast these different branches of biopsychology, because it's essential. So to help you with that, we will test your brain. Alright, are you ready? Dun, 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 dun. Are you ready? Okay, so let's have this. So I want you to, for the instructions, I want you to listen, to look at the different questions there. All of this are fill in the blanks, and then I will pause our video during our FB watch party, and then I will let you answer it. So don't cheat, okay? No cheating, just answer. So this will aid you. Alright, so number 1, a biopsychologist who studies the memory deficits of human patients with brain damage would likely identify with the division of biopsychology termed. Alright, so I will pause. Okay. Alright, so the correct answer is neuropsychology. Alright. Deficits of human patients with brain damage. Next. Biopsychologists who study the psychological correlates of psychological processes by recording physiological signals from the surface of the human body are often referred as. Alright, the correct answer is Psychophysiology. I hope you got it right. Next is the biopsychological research of blank frequently involves the direct manipulation or recording of the neural activity of laboratory animals by various invasive surgical, electrical, and chemical means. The correct answer is physiological psychologists. Next, the division of biopsychology that focuses on the study of the effects of drugs on behavior is often referred as psychopharmacology. It is the division of biopsychology that investigates the neural basis of human cognition. Its major method is functional brain imaging. It's cognitive neuroscience. Alright, next. Blank are biopsychologists who study the genetics, evolution, and adaptiveness of behavior, often by using the comparative approach. You got it right. Comparative psychologists. Alright, so those are the different divisions of biopsychology. I hope you did you were confused at first, but you're able to master. It's okay, go on, keep going. Okay, now we go to the next part, which is the converging operations. So how do they work together? They use different approaches to address a single question, because we know naman that there are strengths and weaknesses that each of the approaches have. So one approach tends to compensate the other's weaknesses. Alright? So for example, we have the Korsakoff syndrome. So the Korsakoff syndrome is characterized by severe memory loss, and it is initially believed to be a direct consequence to the toxic effects of alcohol in the brain. However, with other researches, it's largely caused by brain damage caused or associated rather with thiamine deficiency, although the damage is accelerated by alcohol. So each of the 6 approaches to biopsychological research is not without its weaknesses. So we know that it can be these issues are rarely resolved with single experiment. So in this study or in this example, alcoholics are said not to develop this because most of their caloric intakes comes from the form of alcohol, which lacks of vitamins, and because alcohol interferes with the metabolism of what little thiamine they do consume. However, as other or subsequent na mga researchers were able to find, is that it accelerates the development of brain damage in thiamine deficient rats. So it may have a direct toxic effect on the brain as well. By exploring the possible causes of Korsakoff's using multiple approaches, just like case studies with people of Korsakoff syndrome, tapos we also have quasi-experiments, so comparing alcoholics with people who do not drink alcohol. Then controlled experiments wherein there is a comparison of thiamine deficient and controlled rats. So with this, the strength of these converging operations shows to us that the more diverse the methods and approaches, the more that we can really know more about the phenomenon, which is in this case the Korsakoff syndrome. So as we know, if we just look into one study, it won't give us really a really good conclusion or a generalized one. Alright, so lastly, scientific inference. So how do biopsychologists study the observable workings of the brain. Alright, so we use empirical method that biopsychologists use to study the unobservable. So we use different ways to observe and use measures in the observation in order to infer what they cannot observe, what can't be empirically observed. So brain activity is not directly observable, no, so we cannot really see that the neurons are firing, no, or neurochemicals being released from neurons. So this situation is not really different with other sciences, just like physics. No, we can't directly observe gravity. We cannot see evaporation as in chemists, no, in chemistry. So the effects of the processes are observable, but not the processes themselves. So what we can do is infer. So here's an example of scientific inference. So perception of motion under 4 different conditions. So number 1, eye is stationary and object is stationary. Therefore, retinal image is stationary. So no movement is seen. So parang tingnan lang natin ang isang tree and the outside if you have a tree or whatever that is from a distance. So no movement between the object and also our eyes. So no movement is seen. Next, if our eyes are actively rotated upward, the object is stationary. Therefore, retinal image moves up. So I want you to try it, okay? Okay, no movement was seen. Next, if the eye is stationary and the object moves down, therefore retinal image moves up. Object is seen to move down. Okay, let us try. I want you to try, okay? Alright. Okay, so if there is movement. I tried with my handkerchief. Lastly, eye is possibly rotated upward by finger and object is stationary. Therefore, retinal image moves up. Object is seen to move down. We will try. Okay, so with that, no, it seems like the eye or the object is seen to move now. However, there was no movement. Okay, and if we just used our eyes to go up, no, if we just use our eyes to do that rather than without the finger, there's no movement seen. But if there is the finger that we use to rotate our eyes, there is movement. Okay, so the eye movement example illustrates that biopsychologists can learn much about the activities of the brain through scientific inference without directly observing them. Okay? Conclusion. Therefore, the brain sees as movement the total movement of an object's image on the retina minus that portion produced by active movements of the eyes. It does not subtract passive movements of the eyes. Okay? So, we can only perceive motion if there is that movement, no, of the object on the retina minus the portion produced by active movement of the eyes. But it does not subtract passive movements of the eyes. Okay? Alright, so we use critical thinking in order to evaluate certain biopsychological claims. Alright? It's very important to identify omissions or weaknesses in evidence. So one example here is I will be giving you the link for this, no? So this is the biopsychological research done by Jose Delgado, wherein he claimed that a charging bull could be tamed using stimulation of the caudate nucleus. So what he did was, each time the bull is charged, Delgado used a handheld transmitter. If you were already, if you will see now the video, the electrical stimulation of the caudate nucleus of the bull via the implanted electrode. Then this stopped the bull's charge, and after a few attempts, the bull stood tamely. Delgado and the popular press declared this as an exciting and major discovery, that the caudate is the taming center. It was even suggested to cure human psychopaths. Okay, so however, despite that this is exciting, it really attracted a lot of press, there may be a lot of other possible explanations, so one of which is Morgan's canon. We give precedence to the simplest interpretation of behavioral observation. So alright, so one alternative explanation could be that can abort a bull's charge in a more simpler and more direct way is that the stimulation may have simply rendered the bull confused, dizzy, nauseous, sleepy, or temporarily blind, rather than non-aggressive, or the stimulation could also be painful. So within those, we will really give focus on the simplest interpretation of the behavior. Another case study is Egg's Moniz. So he developed the Prefrontal Lobotomy. It's in which he cut connections between prefrontal lobes and the rest of the brain to treat mental illness. So in 1949, Dr. Egad Moniz, he received a Nobel Prize for this, and he based his technique on a report that a chimpanzee named Becky was easier to handle after part of the prefrontal lobes, the large areas, the left and the right, at the very front of the brain, had been destroyed as part of the experiment. And various forms of the operation were devised, such as transorbital lobotomy, that produce a procedure which is performed by inserting ice pick device into the eye sockets, often in a doctor's office. Alright, so it was seen that it is inadequate to post-operative evaluation of the human patients, and it has a lot of undesirable effects. such as amorality, lack of foresight, emotional unresponsiveness, epilepsy, and urinary incontinence. With this, alright, so that's the illustration, no? The use of leucotome, para yung ice pick device, cutting it, no? Inserting it and then cutting it, cutting each insertion, and cutting the wire was extruded and leucotome rotated, cut the core tissue. It's so horrible. So no program of psychosurgery should ever be initiated without a thorough assessment of the effects of surgery on the large sample of subjects from various non-human mammalian species. So Moniz and others failed to carefully evaluate the consequences of the surgery in the first patients to undergo the operations. The early reports of the operations was therapeutically successful and were based on the impressions of individuals who were the least objective, the physicians who had prescribed the surgery, and the colleagues. Alright? And there were a lot of horrible na mga cases about it. There was even a child who underwent that because it was reported by the stepmom, no, na nagkakaroon siya ng behavioral problems, but it was not necessary actually. No, the behavioral problems were not due to mental illness. So that's why there were a lot of focus on this, no, that we really have to critically evaluate the scientific inferences because lives are at stake. Humans, not only animals, but only, most importantly, human lives are at stake. So that's why it's really very strict when it comes to doing certain researches in human beings. Our first, no, na kailangang take in consideration, we do no harm. Alright, if there is deceit or di kaya a deception that is used, it should be the experiment afterwards should focus on the debriefing of human subjects. So there are a lot at stake, no, with this. So we are very strict. We have an IRB to make sure that our researches are ethical. It will not give harm to human beings. Alright, so that's it. So basically, in a nutshell, no, we had an overview, an introduction to what biopsychology is all about, what are the different na mga disciplines that are related to neuroscience, what researches are used in this field, the different divisions. We also looked into scientific inference and what are at stake, no? That's why we have to really critically evaluate our researches and not just to conclude that this kind of procedure is okay because in the experiment, the invasive experiment that we used in animals. So there should be a lot of trials before it should be given to human beings. Alright, so I think it's very relatable because what we have right now with the coronavirus vaccine. Alright, so that's why we become very wary and we are also vigilant when it comes to taking these drugs. So it should be really, no? I'm very passionate about this because lives are at stake, no? There should be a lot of clinical trials at hand before a certain drug, a certain vaccine should be given, not to a lot of people, because lives are really at stake. It's high stake. Alright, so thank you very much for being with me in our first chapter. So that's it, and I hope you learned a lot. It's a lot. I hope it was not overwhelming. And I hope you did your own readings beforehand, so that in this in this lecture we will just have a brief overview about it, and a more in-depth na mga discussion about it, because I also add certain ideas, concepts, researches that I've found that will be interesting to all of you. Alright, so that's it. We will have our activity or whatever it is after. No. Basta this is the lecture part.